Hi everyone, welcome back to the channel. Before we get started, be sure to subscribe to our channel by clicking on the subscribe button on your screen. Today I'm going to cover chapter 8, Introduction to Metabolism. An organism's metabolism transfers matter and energy subject to the laws of thermodynamics. Free energy change of reaction tells us whether or not the reaction occurs spontaneously. ATP powers cellular work by coupling exergonic reactions to endergonic reactions. And enzymes speed up the metabolic reactions by lowering energy barriers. Regulation of enzyme activity helps control metabolism. So let's get started. So you see here organization of a chemistry of life in metabolic pathways. So it goes from A to B to C to D, and there is a specific enzyme in each step actually required. So metabolism is the totality of the organism's chemical reactions. That can be catabolic pathways, like releasing energy by breaking down complex molecules. An example is cellular respiration of glucose with oxygen, and anabolic versus anabolic pathways, which consume energy to build complex molecules from simpler one. And include an example would be synthesis of protein from amino acids. So energy is the capacity to cause change, exists in various forms. It could be kinetic, heat, potential, chemical energy. Thermodynamics is the studying these energy transformations. There are two laws of thermodynamics. First law of thermodynamics states that energy of the universe is constant, can be transformed, but cannot be created or destroyed. Second law thermodynamics says if energy transform, it increases something called entropy, or the disorder of the universe. So what happens if entropy increases? So spontaneous processes occur without energy input. They can happen quickly, slow, or slowly. For a process occur without energy input, it must be increase the entropy of the universe. So there is something called free energy, which is delta G. Delta G equals delta H minus T times delta S. So the H is the heat and total energy. Delta H is the total energy. I'm sorry, and entropy is delta S, and the unit here is the T is the temperature in units of Kelvin. So free energy and equilibrium. Equilibrium is a state of maximum stability, and the process is spontaneous and can perform work only when it's moving towards equilibrium. So there is also exergonic versus endergonic reactions. So exergonic reaction is that proceeds with a net release of free energy. You can see here, which is delta G is negative, and endergonic reaction, which is absorbed free energy, delta G is a positive number. ATP is a cellular energy unit, which basically we use in chemical transport mechanical work in the cell. Again, it's made of ADP plus inorganic phosphorus. Enzymes they are proteins that they speed up the metabolic reactions by lowering energy barriers. You can see here with enzyme and without enzyme the difference. An example here, sucrose get involved in this reaction with the sucrase enzyme and it's actually break down to the glucose and fructose. Every enzyme must have a substrate. They are like lock and key model, substrate enzyme. And enzymes have an active site. That's where substrate actually bind to this active site. And then when it's done, it's released from there. Every enzyme has a specific temperature, pH. You can see here certain enzymes like low temperatures or body temperature, while other enzymes in bacteria like hot temperatures. And again, same with the low pH with high pH. Cofactors are the non-protein enzyme helpers. They are inorganic. Organic cofactors can be coenzymes like vitamins. There are also inhibitors, and the inhibitors can be competitive or non-competitive. As you see, if it is blocking the active site, that will be competitive. If it is actually binding to a different site, it's non-competitive. And allosteric regulation is when the regulatory molecule binds to protein on one side, affects the protein function in another side. So the enzymes are inactive, and then they can activate it, and again they can be inactive again. Substrate can be something and activate the enzymes. So in feedback inhibition, the end product can actually go and block the enzyme that's actually from the beginning here, like threonine deaminase. This is a type of negative feedback. So this concludes our chapter 8, Introduction to Metabolism, and see you in next video.